Hi, everybody. I'm Flavio Castelli from SUSE. I'm here today to talk about how we build a universal policy platform for Kubernetes. So, what is it? Why did we do that? What is it good for? Stay with me, and you will have an answer to all those questions. So, let's start by talking about some data coming from the CNCF survey of the last year. The survey is done across different organizations, each one of them having a different level of adoption for containers and Kubernetes. You have organizations that are just into the beginning of the journey to use containers and Kubernetes to run their workloads. And then at the other end of the spectrum, you have companies that are already heavy users of Kubernetes and containers. What is interesting is that regardless of their level of experience, all these organization they have to tackle the same challenges. The first one is a knowledge related challenge. So Kubernetes is hard to understand. It has a steep learning curve. It takes time to train someone to be able to use Kubernetes and to use Kubernetes in a proper way, so to say. And the other challenge is how to keep all those clusters secure so that someone that is just using Kubernetes for the first time doesn't do something that leads to a security issue, like running a workload which is not secure, or running that in a non-secure way, giving too many access privileges to a container or to a user, to a service account. This is really a challenging duo, and I think that a proper way to address those challenges goes through the adoption of what is called policy as code. So I guess many of you are already familiar with concepts like infrastructure as code, where you describe your infrastructure using code and then you use certain tools to create and to manage this infrastructure. I'm thinking about things like Terraform or Cluster API in the context of Kubernetes, or CloudFormation, all this kind of stuff. Policies code does the very same thing, but it does that for policies, for rules. So using code, you describe a set of rules that are used to keep everything secure, so to prevent abuses of the system, but also they're used to keep the workloads compliant, so that the people that are starting to use Kubernetes inside of your organization, or the new joiners of your organization, maybe people that are already familiar with Kubernetes, but they're not, they don't know exactly, what are the compliance rules of your organization. These policies, they help you to enforce a really good baseline, to put some guarding rails around, the usage of Kubernetes. And being defined as code means that you can audit those rules. If you're probably going to push them into like a Git repository, so you know who created the rule, who changed it, when, why. You can use testing tools to make sure that the rules are actually working as expected, that there are things that are slipping through them, and what is even more important is that all the organization now, they have to deal with lots of Kubernetes cluster, and you want to have all these Kubernetes cluster to be consistent, to be kept secure. And the way to do that is also by using policy as code, because you can replicate, you can spread this set of rules across all your cluster in an easy way. The policies as code, however, they need a platform on top of which they are executed. These are the so-called policy platforms in the context of Kubernetes, policy platforms for Kubernetes. So on top of being the place where policies are defined, they are executed. This solution, they also give insights about how these policies are behaving. You can, see how many objects that are inside of a cluster are compliant, how many of them are not compliant, what is the reason for them not being compliant. You can also monitor some metrics and for example notice that suddenly there is a spike of rejections, and this looks suspicious, and then deep dive into what is generating all these rejections. Is there some attacker trying to exploit the system, or is it just some misconfiguration of something? So they provide you this kind of insights. All right. And being them policy as code, it means that there is code involved into the definition of those rules. And writing code is something that is highly subjective. So this is another data, this time coming from the Stack Overflow annual survey. Stack Overflow is a really big community of developers, and inside of their survey, they list down all the programming languages that they love, as opposed to the ones that they don't like to use. And I don't want to dig into this specific picture, because actually this is a really long list and I had to trim it down. What I'm pointing out with this list is that there is no unified way of writing code. Writing code is opinionated. Some people prefer to use a certain language as opposed to others. Other people know many programming languages. They have their toolbox with many tools inside of them, programming languages, system libraries, tools, and they love to pick the best tool to accomplish a certain job. It's like you don't just have an hammer inside of your toolbox. You can't use an hammer to fix everything. You need other tools, and you need to be able to pick the right tool to address the problem, right? And to go back to the first slide I've shown, there is this challenge of training, and this is all connected, I think, because when you go inside of an organization, you suddenly have individuals, and each one of them with their unique history, their unique knowledge, competences. And you might have someone who is a developer that is really familiar with a bunch of programming languages, and then you might have someone who is instead doing DevSecOps and is not as proficient as a developer with these programming languages, but instead is really proficient with a domain-specific language, in this case, Rigo for Patricia. And so what you want to do inside of an organization is to have everybody able to review the policies that are enforced, to write new policies out of the box without having to train them in a really specific way. You want to be able to leverage their pre-existing knowledge. All right. Also, talking about the kind of problems that the policy has to address, the kind of language, the kind of approach to be taken to address this challenge varies a lot. For example, if you want to write a policy that does some validation against labels of resources, you can probably write that with Go. But if you write that using which is a traditional programming language, but if you use instead a DSL like Rigo, for example, you can get the job done, but maybe writing fewer lines of code. Um, on the other end, if you want to write a policy that is looking for secrets being leaked, be them like AWS tokens, SSH private keys, and a bunch of other kind of tokens, you probably need to leverage. You can save a lot of time by leveraging a pre-existing library. So use a traditional programming language in that case, and also use a library that someone has already written that can quickly spot this kind of secrets by just looking at the contents of strings. So again, depending on the kind of problem that you have to choose, even if you are proficient with any kind of programming language, and be them traditional ones, DSLs, you will probably end up picking a different tool to accomplish the job, just to be more uh, fast in resolving the challenge, produce some better code. Having choices is always good. All right. And that leads us the desire to leave options to policy authors that lead us to the idea of creating Kubernetes and having Kubernetes be a universal policy platform. With universal, it means that we want you to be able to run to write policies in different kind of programming languages. More on that on the next slide. First of all, let's do a really short introduction about Kubernetes. Kubernetes is an open source project that was initially created by Rancher, but is now part of CNCF. We donated the project to CNCF. We are actively maintaining it together with the Kubernetes community. And as I just said, Kubernetes allows a policy author to write a policy using a traditional programming language like Go, Rust, and other ones, or to use a domain-specific language like Rego, which is the language that has to be used when using OPA or Gatekeeper. We are also working to have support for Cell, which is another DSL that is now being added to do some validation to Kubernetes itself, starting from the latest release. And we are even working on adding support for the Kyverno DSL, which some administrator found really comfortable, to be used, while other people they just feel like I'm not proficient or I can't do complex things using it. The point is there is no right or wrong approach again when writing policies. It all depends on the policy offer, and it depends a lot on the problem space, the challenge the policy that you are trying to write. So how do we achieve all of that? How can we give all this flexibility when writing policies? And we do that by using WebAssembly. So I don't want to dig too much into WebAssembly. This is kind of out of scope for this presentation. But to give you just a short overview, you write some code using your programming language or your DSL, and then you compile this code using the compiler of that language into a WebAssembly module. So instead of compiling that for the Linux operating system and the Intel architecture, you use as a target the WebAssembly word. And then you have this portable binary that you can take and run on top of Kubernetes. Uh, what is really interesting and I want to highlight is that you, as a policy author, you write your policy, you compile it once, and then this module, with no modification, it can run on top of Kubernetes, and it doesn't matter if the underlying operating system is Linux, Windows, or Mac. It really doesn't matter. It doesn't matter if the underlying architecture is Intel, is ARM. Really, this is a truly portable code. And given its code, I want to give you a quick glimpse at real examples coming from policies. This is a policy that does validation. It's written in Go. I don't want to look at it line by line. What I want you to grasp is that, if what I want you to understand is that if you are a Go developer, if you know how to read or write Go code, if you take a look at this slide, you will definitely understand what is going on with this policy, because this is definitely pure Go code. No need to learn anything new. And at the same time, this is another example. This is a mutating policy because we can do mutation. This time is written in Rust, and again, this is traditional Rust code. So if you look into that as a Rust developer, you will definitely understand what is going on. And here, highlighted, I show this mutate request function being invoked. What I want to point out is that we offer SDKs to our policy authors that they can leverage to perform common operations in the context of writing admission policies. And the key point here is that Kubernetes requires, in this specific case, it requires mutating policies to produce a certain output. We do not want policy authors to understand, to learn how Kubernetes wants the output to be formulated. The author, they just use a high level function and they just provide the object that has to be patched, and this is it. All the complexity is done behind the scene. And in the same way as they can import our SDK to write their policy, they can also import other libraries from the Go ecosystem, from the Rust ecosystem, and so on and so forth, and leverage those libraries to accomplish tasks. So this is again, being able to reuse all the processes, all the workflows, all the ecosystem, all the tools that they're already familiar with. Last but not least, I mentioned that we have Rego support. Rego is a query language that is used by OPA and Gatekeeper to express their policies. We can compile Rego into WebAssembly and then just run these policies on top of Kubernetes. No need to change them. It's really just a one-to-one translation. Now, we have seen how to write policies. I want to now focus on how to actually deploy them, enforce them, operate them. And again, the thing is, we don't want to put any burden on the operation people. We don't want them to learn new tools. We want them to be able to leverage their existing infrastructure, their existing processes, workflows, and let them be able to just reuse their knowledge and be as productive as possible. How do we do that? First of all, I want to point out that all our policies are WebAssembly modules, as I said. And from the operational point of view, it doesn't matter what kind of programming language or DSL was used by the author to create this WebAssembly module. From the operational point of view, it all looks the same. These are just WebAssembly modules, but they have to be pushed somewhere and then used inside of a cluster. How to move all these policies? Well, easy. We are just using container registry. So the same infrastructure that you use to host your container images, we're using that also to host the Kubernetes policies, which also means that all the set of processes, workflows, tools, solutions that you use to manage your container images, they can also be used to manage your policies. How to distribute all the policies across the clusters? Well, it's the same way that you use to distribute container images. Again, no need to learn anything new. Also, there are a set of other operations that are done by Kubernetes administrators, and also for that, we want just to have policies behave like traditional applications. First one, for example, custom resource definitions. We have custom resource definition that simplify the process of deploying these policies. So we have here a custom resource called cluster admission policy, which is used to deploy policies that are looking into cluster-wide resources, but also they are able to look into resources created into any kind of namespace of a cluster. You just have to specify what are the resources that are relevant for the policy, what are the operations that are relevant to it, and eventually specify some settings for this policy. In this context, in this case, we have a policy that is looking to pod creation and updates. It's a policy that can also perform mutation, and it has some specific settings. Now, this kind of custom resource, the custom mission policy, is meant to be used only by the administrators of a cluster, because admission policies, they are pretty powerful. They can look into any kind of thing, and so we don't want to have regular users of a cluster to mess with system-wide resources or resources that do not belong to them. If we want to have some users manage their policies, we have another custom resource which is called admission policy, which is names based, which means that you can safely allow a tenant, for example, to define his own admission policies inside of the namespaces where he has access to. So they can define, this is the same policy shown before, but this time is being deployed inside of a specific namespace. But as you can see, the behavior is basically the same. Now, in terms of other operation aspects of policies, Observability is a key factor, for any kind of application deployed inside of Kubernetes, and that includes also policy as code. At least this is what we think. So we have an open telemetry integration, and we leverage that to expose metrics to Prometheus, which means that you can then define alerts, you can create dashboards with Grafana or other solutions, and have always under control what is happening inside of your cluster. As I mentioned before, this is really useful because, for example, if there is a sudden spike of rejections, you probably want to know why this is happening. Who is originating that? Is there an attack in action, or is it just some misconfiguration? And in order to better drill down into the specific, we also have an integration with Jaeger, which allows you to look into all those rejection requests, for example, and then figure out who is originating them, what are the traces that are emitted by the policy when evaluating those requests. And I think that is really important to point out that these are all kind of debugging techniques that are used to look into microservices applications, and an operation folk can leverage all this knowledge he already has with regards to debugging microservices applications. He can reuse that also to figure out what is going wrong with policies inside of his cluster. So again, it's always a matter of allowing people to reuse their knowledge, to reuse their processes, the processes defined inside of the organization. Talking about Rancher, we do have a Rancher extension that allows the easy installation and update of a keyboard and stack. It also allows you to find policies ready to be used, to install them, to update them, and really important to monitor them to see how they are behaving, to know what is going on with them. And all of that is available to you through the familiar user interface of Rancher Controller. I mentioned ready to be used policies. That's because you don't have to be a developer in order to use Kubernetes. You can be a system administrator who just leverages policies made by trusted parties. So if you go to Artifact Hub, you will find more than almost 30 policies coming from SUSE, coming from other independent authors, and then you can just reuse them. So no need to write code in order to consume them. You just have to write the YAML file required to deploy them, or you just use the Rancher extension and do all of that through the Rancher UI. So to recap, lack of training, keeping clusters secure, these are the major challenges of many organizations, regardless of their level of experience with Kubernetes or containers. We think that policy as code is the right approach to tackle, the security implications, is part of the solution, in order to have secure clusters. And if you use Kubernetes, you will be able to reuse the existing knowledge that is inside of your organization, so that everybody inside of your organization, be them developers, DevSecOps, DevOps, they can write policies, they can review policies, which is extremely important to know, how a policy evolves over the time. And from the operational side of things, there is no need to introduce new infrastructure. You can reuse what you already have, not just in terms of infrastructure, but also in terms of tooling and processes. You can just stick to that. If you want to learn more about Kubernetes, or if you want to get in touch with us, there are a bunch of links over there. We're looking forward to talk about Kubernetes and policy as code. So feel free to reach out. I hope you enjoyed this presentation, and I wish you happy conference. See you. Bye bye.